this video, we'll add artistic controls to a skill tree which is procedurally generated. We'll accomplish this by integrating the variables we use to have that artistic control into the right spots in the procedural generation blueprint code. Go into the components folder and open up the component base. And we'll add some variables here that we can use to control the procedural generation, control the way that it looks. But before we do that, let's start cleaning up our variables a bit by putting them into categories. One thing that's worth mentioning is if you use a vertical line in the name, it will create a subcategory. So for example, we could type skill tree vertical line start, enter, and then you can see over here it's created this category skill tree and also this subcategory start. And the reason this is worth doing is because if we come over here to the child component, which remember is the one that we'll be using to control everything, the skill tree now has these subcategories, which will be quite useful because we'll have a lot of controls in here. And this is the way I've organized the variables into categories if you want to copy me. So we're going to add these new variables to the tree appearance category because they're going to change the way the tree appears. So we'll duplicate the bottom one because this is going to be a float that goes in the same category, and we'll name it tree rotation, duplicate again, degree span, duplicate again, tier distance, again, edge buffer, and one more time, counterclockwise question mark, and the last one we can make a bool. The degree span, we can set the slider range over here from 0 to 360, compile, and slide it all the way up to 360. And the tier distance, we can set a default to maybe 350. Tree rotation wants to be 0, and we can set its slider range from 0 to 360 as well. And edge buffer wants to be 0, and counterclockwise can be off by default. Compile, and we want to add these variables to the get tree info interface function to pull these variables in with these. So we'll go to MISData, open up our interface, open up the get tree info, and add these outputs here. And compile, close the interface. Now we can just input them here. And for the tree rotation, let's subtract 90 by default. And this is because the default rotation in Unreal Engine will send it out to the right, and this will instead send it up above. It's just a design choice. So I'll add a comment, compile and close. And now in our skill tree widget, in the catch skill tree component and info function, we see these new outputs, and we can promote them to variables and put them in the node generation category. And just remember as a note, this showed up as tier distance 0 because we already created tier distance before, so we'll delete that. And we'll add in our tier distance that we created before and set this to that variable. And we can also mark all these variables as private because this is the only thing that's ever going to be setting them. So now that we've pulled all the info from the component into the skill tree widget, we can close this function. And in the calculate node location function, we can use these variables to give more diversity in the procedural generation outcomes. So the first thing we'll do is at the top here, we will directly add the tree rotation and degree span into here. And after this first chunk is done, this first operation, we're going to calculate the buffer angle, and this will be the angle between the groups of nodes, so we can kind of have more spread between the groups or more clumping within the groups depending on how you look at it. So we'll add another pin here. I'm just control dragging these two down, and now out of the one output we'll take that edge buffer, and we'll also get the tier distance, multiply by the local variable parent node info, split it, the z value, plus 1. And what this little chunk is, we'll comment it, this is the node distance from center. So we're going to safe divide the edge buffer by the node distance from center, and we need to convert this to degrees now. And in case you're wondering what this whole chunk is here, we can just comment this. This is the tangent. Because if we remember from trigonometry, tangent equals opposite over adjacent. And we'll just clamp this. So remember, the y value is the degree span. We'll divide by 2. In other words, taking half the degree span, because from the center point it's only half either way. And we'll clamp between 0 and half of that. And we're going to promote this final output to a local variable, and we're going to call it buffer angle. And this is the one that we'll use in this function. You can double click on the wire to create a reroute, and we'll comment the whole thing. So now that we've calculated this buffer angle, we're going to insert it into our math down here to calculate the location of each node. So remember, this chunk calculates the starting degree of that node radially. So we're just going to add another pin here and drag in buffer angle so it'll start that much later. And remember, down here is the degree span. We also need to factor in the buffer angle. We'll just subtract 2 times the buffer angle from this. Now the last thing we want to do is add in this functionality to generate it counterclockwise if we want. And one elegant way we can do that is, instead of plugging this cosine directly into the x of the vector, we can give the option to mirror only the x but keep y the same if counterclockwise is enabled. And that will have the effect of generating it counterclockwise instead of clockwise. So we'll just drag the counterclockwise bool in, do a select float, plug it into the x, multiply, plug this into the x, drag this down here, multiply it by the cosine d. If it's a, it's going to be -1, and if it's b, it's going to be 1. You can reroute this around here for organization. And we can comment this. Just make sure that all of the variables are set back to their defaults. Make sure there are no arrows over here. If there are arrows over here, just click on them, and then the child will be the same as its base. And the same in the player controller. If you want to open that up, make sure there are no arrows over here, and just click them, make sure they're the same as the base. Basically, you want to make sure degree span is like 360 or something much more than 0. And then tier distance also shouldn't be 0. And then when we open it up, we'll see that we have our skill tree. And now in this child component that we're using, we can play with these parameters and see some different results. For example, if we set the degree span to 180, this is now the result. And if we set the tier distance to something lower, this is the result. And if we give it some edge buffer, you can see these nodes in this group are starting to clump together a little bit more. Let's say we just want the nodes spawning at a downward 180 degrees. Well, we can give it a 90 tree rotation and a 180 degree span. And there we go. And remember, this one has these 2 spawning out, but if we were to have 2 spawning out from each of these, it would be perfectly symmetrical and just going downward. Let's test out the counterclockwise. And there we go. So now we have a lot of control over how our skill tree procedurally spawns, which is controllable with sliders in the component, and we never have to manually place any of our skills. So our skill tree is starting to look pretty good, but one problem is currently all of the nodes, all of the skills are kind of just floating in the air. A lot of times skill trees will show the connections between the different skills to make it more apparent what unlocks what, or what goes to what in the hierarchy. So for the next video, we'll design the connections between the nodes in much the same way that we designed the background for the node widget, making it extremely customizable, and we will procedurally place them on the graph.